When we deal with quadratic functions, we can always express it in three different forms: vertex form, general form, and intercept form. To find the maximum or the minimum point for the quadratic functions, we must always express it in vertex form. This is the format for vertex form. Pay attention to h and k, because h and k is going to be the x value and the y value for the coordinates of the turning point for the quadratic functions. And if you were to change the quadratic functions from general form to the vertex form, the process of completing the square must be done by changing general form to vertex form. So today we will talk about the method of completing the square, changing it from general form to vertex form to find the turning point, be it maximum or minimum point for the quadratic functions. However, actually this is not the only way to find the turning point. You can use other methods to find the turning point as well. For instance, to utilize the equation of the axis of symmetry, where it goes with x equals to negative b over 2a, axis of symmetry, or we can use the concept of differentiation, f prime x equal to 0. However, we'll talk about completing the square in this lesson, so emphasize on this one. And there are a few things you need to keep in mind. The first thing, a, remember, ax squared plus bx plus c, your a must be 1. Else, if it's not 1, then you have to factorize it. Make sure it is always equal to 1 for a. And when you do the completing the square, this is always your first step. For the first step, you must pay attention on b, and this is how you write: b over 2 square minus itself. b over 2 square minus b over 2 square. And this part, b over 2 square minus b over 2 square equal to 0. So it makes sense because it comes from nowhere. So we have this format. To further demonstrate how to apply this into the mathematical problems, let's have a look on these questions. The minimum value of this quadratic function is m squared plus 2n. So when we look at the word minimum, you know that this quadratic function has a minimum point instead of a maximum point, right? Minimum value. Or you can check here, since a equals to 1, you know that a is bigger than 0, greater than 0. Therefore, this is a U-shape and has a minimum point. And so on and so forth, b and c. Okay, so you should be able to figure out a, b, c here. And this is the minimum value. When we have a minimum value, do we refer it to x or y? Right? Minimum value, this is referred as y, or you can call fx. This is your minimum value of y. Where m and n are constant, fixed, show that m equals to n minus 1. So you can use many methods to find the maximum point or the minimum point. But in this case, I want to show you how we did it by using completing the square. First thing, pay attention on b. b is negative 4n. What do we write in between? Right, so replace b with negative 4n. And can we simplify this part? Negative 4n over 2, negative 2n. Okay, what's going to happen next is these three terms. Focus on these three terms. I will turn these three terms into a brackets, a square, and the format go with x. So you put x, always x, and then you put in what within these brackets, negative 2n. So you put x minus negative 2n square. Okay, many of us will have doubts on this part. What happens? How do we turn these three terms into these two terms? This is a process of factorizations. And how do I know about it? Okay, I can show you this. What is the opposite process of factorizations? What do you call that? Opposite process, the reverse process. Expansion, yes. Okay, I'm going to show you these expansions. Okay, so let's say we have, this is what I have. So when I expand it, right, and then I can choose to change this one to bracket 2n bracket square, and then compare this to these parts. Okay, compare this one and this one. Is it very similar? Is it very similar? The only thing is different is we have a negative here. Here without a negative. Is it the same? Okay, let's check it out. So when I have 2 bracket 2n squared, do I have 4n squared? Yes. So when I have negative bracket negative 2n squared, do I have 4n squared? Yes. So you can put a negative if you want to. So it makes sense anyway. So these two, you compare and see, would it be exactly the same? Yes. And what you call this? If this process you regard as expansion, then this process you should call it factorization. So what happened here is we have done the process of factorization, and then we continue with the following parts, which is negative 4n squared plus 5n squared plus 1, and your final answer should be, okay, keep in mind, why do we express in vertex form? Because we want to compare and then to see which one is the h, which one is the k, because hk is going to tell us what is the coordinates for the minimum points. H is 2n, so you put 2n here, k n squared plus 1. So this is your minimum point in terms of n, 2n and also n squared plus 1. Are we done? We are not done by finding the max minimum point. What we need to do is to show m equals to n minus 1. Okay, do you remember this part? Did we apply this one? Did we use this part? M squared plus 2n is the y value for the minimum point. So this is part of the minimum point and we refer as y value. M squared plus 2n y value. So m squared plus 2n should be equal to this part, right? This is also the y value, both referring to the same point, the minimum points. So let's say this is the same, you can write as m squared plus 2n equal to n squared plus 1. There should be the same value. And you can group the same variable at one side. Alright, and you factorize it. Now when both sides have the same power, you can ignore it and compare what's within. And this is your last step. Done, right? We have shown it, right? M equals to n minus 1. Done. Yup.